Welcome to homework.
Okay, we want the resultant to act along the y-axis. So I'm going to begin by drawing what we've got here. X, Y, Z. I'm guessing that F1 is along the x-axis, even though it doesn't really look like it is to me. But I don't see any indication of an angle there. F2 looks like it's going here. And we're given its direction in the XY plane. So there's a right angle here. And there's also a right angle here. So that this is 40. And this is 30. And then we've got F3. It's going, whoops, somewhere up here. Okay, so let's go ahead and resolve F2 into its components, because F1 is just in the negative x direction. F2 is going to have a z component, an x component, and a y component. So F2 in the xy plane is going to be F2 cosine 30 degrees. F2 in the x direction is going to be positive F2 cosine 30, which is F2xy. And then that's going to be the sine of 40. F2y is going to be F2xy cosine 30. Only, no, it's still in the positive y direction. So let me just think here. It's going positive y, yep, and it's going positive x. In the z direction, it's going negative. Negative F2, and that's going to be the sine of 30 degrees. All right. F1 only has an x component. I'm going to write it down here. F1x is negative 180. And then we need to add that to F3 so that the resultant is along the positive y-axis. All right. So F1x plus F2x plus F3x would be 0. Now, F3 appears to be in the negative x direction. I think I'm just going to remember that I generically just put F3x down there. So if the answer is negative, it will be in the negative direction. If the answer is positive, it will be in the positive direction. Okay, so f3x is going to equal f1, the opposite of f1x plus f2x. Now, in the y direction, you want the resultant to be 600. So f1y plus f2y plus f3y equals 600. So f3y is going to be 600 minus f1y minus f2y. And f1z plus f2z plus f3z is 0. So f3z is the opposite of f1z plus f2z. So let's go ahead and calculate those. Wish you could see my calculator, but it just slows down my computer way too much to have it be recorded. So I just need to tell you what I'm doing. So I'm going to do f3x, so it's going to be negative parentheses f1x, where's my f1x, is negative 180. Yeah, I forgot, f1 only had one component. My goodness. Plus f2x. f2x is going to be f2, 300, cosine of 30, sine of 40. That gives me 13 pounds. Seriously? Okay. The opposite of that plus that. Okay. So f3y is going to be 600 minus f1y, which is 0. So is f1z, by the way, minus f2y. Well, f2y is f2, 300. Oops, where is it? 300 times the cosine, 30 times the cosine, that should be a 40 there. That would be 401. Nope, 401. Be 401. Okay, f3z is just going to be the opposite of f2z. 2z. So f2z is negative, so the opposite of a negative is a positive. So f2 is 300 sine 30. 150. So I see that they're all in the positive direction. Interesting. Wait a minute. Wait a minute. Now that makes sense. Yeah, makes sense. Okay. Determine the magnitude and coordinate direction of F3. So now I need the magnitude of F3. Square root of F3x squared plus F3y squared plus F3z squared. So let me put that into the calculator. square root of this squared plus this squared plus this squared. 428.3. So let's see if that's correct before I continue. 67, 428. Very good. Okay, so now alpha would be the inverse cosine of f3x over f3. Likewise, beta and gamma. So I will get all of these. Okay. Inverse cosine. This over a whole thing. First one's going to be 88.3 degrees. The second one is going to be, putting F3y in there, 20.6 degrees. And the third one going to be 69.5 degrees. And again, I'll check that work.